Okay, good morning everyone. Let me go with the experiment 5. This experiment 5 is all about the design of Verilog code for the decimal adder. So this is all about the decimal adder. So now what it tells is decimal adder. So now I'll take one example 3 which is written as what? 0011, and I'll take one more number 4 which is written as 1000. So what is the sum of this? 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1, 1, 0. So the sum is 7. So if sum is 7, then this is correct. First of all, I should explain you what I mean by BCD number. BCD numbers always, it will be in the range from 0 to 9. 0 to 90, right? 0 to 9. So now 3 is a BCD number. Why? Because it is within the range 0 to 9. 4 is also a BCD number. It is in the range of 0 to 9. And my result 7 is also within the range of 0 to 9. So this is what we call it as a decimal adder, where I add only the numbers between from 0 to 9, which is a BCD number, and my result should also be in the range from 0 to 9. Now this is what we call it as BCD addition, or we call it as decimal adder. Now in this case, let me take with another example. Now let me take the one number is 4. Let me take it as 4 0 1 0 0. The other number is 6. That is 0 1 1 0. Now I'll add these two numbers. So 0 0 0. 0 plus 1 is 1. 1 plus 1 sum is 0. Carry is 1. So 1 plus 0 plus 0 gives me this 1. So my final result is 1010, which is actually the number 10. So whether this 10 will come to the range from 0 to 9? No, it won't come. It is apart from this range 0 to 9. So now since my result is exceeding this range, so this is not my final sum. This is not my actual sum. The sum is not correct. It is incorrect. To make this a correct result or a correct sum, what I should do is that for this 1010, I should add a number 6. I should add a number 6 for this, which is 0110. So now 000, 110 carries 1. So 1 again, 0 carries 1. 110 again. Now the carry is 1. This one is treated separate. Now you can see, now the sum what is being come here, it is in the range 0 to 9. So now this is the correct sum, and now what I have got is the carry. Now the carry is 1. Now the question is, why to add 6 for this? See, normally what happens in any kind of hexadecimal number will range from 0, 1 to 9, and then afterwards A, B, C, D, E, F. Correct? So now this, how many numbers are there? Characters are there. A, B, C, D, E, F. 6 characters are there. So that is the reason I should add 6 for this particular number when it is going to exceed the range from 0 to 9. So in this fashion, we are going to perform a BCD adder or a decimal adder. So now this is the truth table I have written. So where truth table tells that if my result is in the range 0 to 9, so this is the 9, 1001 means 9. Within that, my output will be 0. That means it is correct output. If it is exceeding 9, then it is going to have my output as 1. So for this truth table, I have written a K-map here. Now when I write a K-map, I have grouped the cells there. So where I got my expression as y equals S3S2 plus S3S1. This is the expression I have got it. Now this explains me the binary adder, how actually it will get added. So now I have taken two numbers A0 to A3 and B0 to B3, and that is what it is referring to these numbers. So this is A0, A1, A2, A3. This is B0, B1, B2, B3. Right? So now these four numbers has been added, and the result what I am getting is here S0 S1, S2, S3, and that is where here. So now what happens, when it is in the normal range, when it is a correct sum, there is no issues. So sum will be taken as it is. My output of the sum will be S0, S1, S2, S3. The output will be, whatever the outputs I am getting here, that will be copied as it is in this next 4-bit adder. If suppose, if this sum is exceeding this range 0 to 9, in the previous example I got it as 1010. So when such things is going to happen, then it is going to perform this calculation S3, S2 plus S3, S1. That is where I have written here. You can see here. See, this is S2 into S3. This 2 I have given it to an AND gate, and this is S0, S1. And again, it is going to an AND gate. So this gives me S3, S2, and this gives me sorry, I think I should have written here. This is where S3, S1. So this is S3, S1. So this is the formula what I am supposed to get for this. Right. So when I do this, this gives me y equals S3, S2 plus S3, S1. Now that means that here what is going to happen here, you can see these two lines are value 0, 0, right? Now the output of this AND gate is given to 1, that will produce 1, 1. So what is the number here? It is 0, 1, 1, 0, which corresponds to a decimal 6. So that means when it is going to exceed the number 1010, so suppose I got 1010 here as an output, this 1010 will get added with 0110, that is what I have done here. And the final result is what I will be getting here 0000, and along with this I will be getting on carry C out, which is written in this box. So this is overall explanation of my experiment of 5. Now we will go with the Verilog code. So this Verilog code tells module, BCD is the name. So I have the parameters here, A, B, carry in, sum, carry. Now I have the input 3:0, A, comma B. I hope you understood now. Before this experiment I explained what I mean by 3:0. It is giving me A of 0, A of 1, A of 2 and A of 3. So similarly, I have input carry underscore in, output 3:0 of sum, output carry, reg 4:0, sum underscore temp. This is the temporary variable I have got it actually reached, and reg 3:0 sum and reg carry. So I have got all these things. Now I am writing a behavioral model program, always at the rate A comma B comma carry in. When these things are going to change, then what I am going to do, I am going to perform a summation here. Sum underscore temp equals A plus B plus carry in. That means I am adding these two numbers. A, this is the A value, this is the B value. If any carry in I am getting here, so that carry will also be added with this sum. So finally, that result A plus B plus carry in is stored in the result sum underscore temp. Now this is the sum I got. Now I should check whether this sum is in the range 0 to 9. If it is greater than 9 or less than 9, I should check. For that, if sum underscore temp, if it is greater than 9, then I will write beginning my code, begin sum underscore temp equals sum underscore temp plus 6. So this is what I have done here. Plus 6 I have added here. The same thing I am doing it here, plus 6. Once it is done, I am making my carry also equal to 1. So carry also I am going to make it as 1. Next, finally, whatever the sum temp value is there, all those values I store it in one more variable that is called as sum. Now this is where I end my program for this if. So begin I started, I am doing an end here. Next, else, for this if there is an else part, so in the else part begin. Now I am making carry equals 0. That's all. If suppose if it is not greater than 9, this is the case, then only I am going to have only this number. No carry is generated there, so carry will be 0 always. So carry is 0, and what will be the sum? Sum equals sum underscore 10. Whatever the sum is stored here, the same value I am going to store it in sum. With this, I have written the end here. This end is for this begin. Correct? Okay? And this end is for this begin. And this end module is for the module which was started at the starting line. So this is the Verilog code of this experiment, and this is what it explains about the decimal adder. Thank you very much.